Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan binti Sulaiman. So I will present my final year project about hybrid renewable energy system study at Conservation Park. So I will introduce myself. My name is Muhammad Irfan binti Sulaiman. So my supervisor is Associate Prof. Dr. Azlin Muhammad Azmi. So he will supervise me for the topic hybrid renewable energy system. Okay, so my presentation consists of 4 chapters, which is project summary, introduction, methodology, and expected results. Firstly, for the project summary, I will go to the next slide. Rural places have generally limited energy facilities. According to the 17 goals of sustainable development, also provide a requirement for clean energy, which is the 7th goal. It shown that the energy is necessities of life, same as water and food. However, it comes with challenging to set up the clean energy system in rural areas. This project is to study the best hybrid renewable energy system in a selected conservation park based on technical and economic aspects in order to supply and maintain the energy. This project will use Homer Pro software to recommend the best system from the different system configuration. Hence, this study will define an effective design for hybrid renewable energy in a conservation park. Outcome from this study should provide useful information for creating a hybrid energy system that works well in a conservation park. Next section is the introduction. Energy is foundation of a nation's social and economic stability. The current population growth, the desire for higher living standards and industrialization are all contributing to a progressive rise in energy demand. The source of energy mainly use the fossil energy source. Oil, coal, and natural gas are examples of non-renewable fossil energy sources that were created when extinct. Prehistoric plants and animals were progressively burned under layer of rock. The best replacement for fossil fuel in the production of power is considered to be renewable energy, and it is aligned with the limited energy resources in rural area. So, the examination of other options is typically prompted by the lack of electrical networks in remote area. To electrify off-grid rural area, solar PV energy technology is seen to be the most effective option. So, on a side, this can be alternative for support for small business and household activity, which usually use the diesel generator. So, when use the renewable energy, we also have the environmental friendly, which is it is technology by the solar PV, since it creates no greenhouse gas GHG emission due to reduction of carbon dioxide emission and no noise while operating. So the renewable energy sources are prevalent throughout most of the world and can be used for unlimited access. By its name, hybrid renewable energy system refer to a set of 2 or more energy sources to electrify a load locally in standalone mode and where appropriate work in parallel with grid power system. Power generation typically combine renewable energy sources such as solar, wind, and geothermal energy with common conventional sources include fuel for diesel generator. So basically, HRES has 2 options, which is first, switching to renewable energy sources, and second, creating a new, more decentralized or distributed energy paradigm based on solar, wind, and battery storage. For switch, we can use the sources that existing at the selected area and also consider biomass and mini hydro as sources. But this will further analysis for next FYP. For this study, we'll focusing on solar battery and generator. This project study was carried out at the conservation park to determine the ideal hybrid renewable energy. So the project begin with assessment of load consumption profile based on existing data. So basically this literature review from the four, starting for El Hauri, which is to supply electricity for 10 homes in this 10 village. Next, Saif Pur Rahman for off-grid rural electrification on southern Pakistan. Next is Amanda Halim for method for designing and sizing HRES, and also Ageto Energy, which is they decide to the best mix of solar PV, batteries and generator. So in the conservation part, the electricity is the necessity for the community to continue their activities while keep preserve the environment. So that is the problem statement for my FYP. So for the objective, we have two objectives. Basically, first is the to design a hybrid renewable energy system and its feasibility at a conservation park. Second is to examine the levelized cost of energy and net present cost of the proposed HRES. So basically, this study will conduct at the recreational camp at State Park at Real Belum, Perak, which is firstly Sungai Keja, second Sungai Tiang, and third Sungai Kenarong. So in order to have an electricity but at the same time to reduce carbon emission, fuel transportation costs and noise pollution, and alternative energy system is required. So for achieve that, hybrid renewable energy is suggested. And the study is about gaining the best configuration of the system, and practical experiment will not be performed except for either the result from the Homer software. Next for the methodology. So this is flowchart of the methodology, which is first gathering data at energy demand at campsite. Next, assessment of load consumption profile. Third, which is total load profile at campsite. And next, the simulation a hybrid energy system using the Homer software. So next, the step is the foreman analysis of the hybrid energy analysis. So we will get the technical of best system and list of system option. Next, also we get the economy of system, which is the minimum cost and initial and maintenance cost of the system. So basically for the Homer software, and Homer stands for hybrid optimization of multiple energy resources. And its function is microgrid analysis tool to determine the viability and potential configuration of HRES, and is developed by US National Renewable Energy Laboratory and REL. So the parameter used for this study is using levelized cost of energy and net present cost. This is basically a schematic diagram of HRES that proposed at the selected area, which is has a generator, electric load such as lamp and fan, converter, battery, and also PV solar. So basically, this is a value we use in the Homer software to generate the option for hybrid energy system. The value can be referred in the table. And last, the expected result. So from the result, we get the PV battery as the low COE and NPC. This result is for the expected result for campsite Sungai Papan, which is other campsite from the another tree that we want to study. So the results show that we'll use the PV, which is 5.84 kilowatt, and battery bank, which is 9 kilowatt. The result also calculate for ROI, IRR, and a simple payback result, and which is return of investment, IRR, internal rate of return, and simple payback. So it also shown the PV battery is the best option, which is 11% for ROI, 60% for IRR, and 3.9 years. So basically, this PV battery is the best configuration system, but this study need to further analysis, which is to determine the accurate price for the component for in the system. So that's all from me. Thank you.